In this set of videos, we're going to go over what is known as domain and range. It's really important to know what domain and range of functions are. Okay, so I'm going to define them first. The domain is, in essence, it's the list of all possible x values, right? So that is on the x-axis. And the range is the list of all possible y values. And in our study of domain and range, the previous video on set notation will become really, really important. All right, so what I'm going to do is I'm going to basically explain domain and range by showing you a few examples and showing you how to define domain and range based on those examples. So let's go to here. So let's say example 1. So say, for example, I take the function, so let's say f of x is equal to 2x plus 1. All right, so let's just see how that looks like. So let me just, oh, that's white, it's perfect. So I have that there, and then I have that here, let's say. So let me just pick another color let's pick red. So we know that the intercept is 1 and the slope is 2. So I'm just going to go up something like this, okay? And let me go back here. All right, so I know that, for example, the intercept is 1, all right? So let's say, so what we can observe, for example, this line extends forever. This line extends forever, as well as in the back end, it sort of extends forever. So it goes down all the way here and down all the way there. So remember, domain stands for list of all possible x values of a function, and range stands for all the possible y values of a function. So, for example, if I draw sort of like an imaginary line, let me pick, yeah, I'll stick with yellow. So if we observe over here, if we observe over here, if this is, let me just pick yellow here, and hopefully that's yellow, okay, great. So let's say if I go here, so if that represents all the x's, and then the blue is the actual possibility. So therefore, since it goes till infinity, it goes forever, and goes forever right there. So this is 0, and it goes towards infinity. So all the x values are part of the domain. And this similarly, if I basically show the yellow over there, so let's say if I do the same thing for the y's, so this is sort of representing all the y's, and the blue that the blue color I'm going to use is the possibilities for this function. Since it extends forever, well, all the possible y's go forever, right? They go forever in that direction. So the domain is all the possible x values. Oh, and by the way, here's 0. And the range is all the possible y values. And they both extend forever. So how do we write the domain and range? So in this case, the domain, which I'm going to call D, the domain is x is element of all the reals, right? Because it represents all, because for this function, since it extends forever, the x values contain all the real numbers. And for the range, we say the y, and since there's no restriction whatsoever, we simply say y is element of reals as well. So for this function, in this example, we can see that the domain and range are the same effectively because they extend out forever and there's no restriction. All right, let's get to some more interesting examples. So let's do example 2. So example 2 is like very similar, and I'm going to say f of x is basically 2x plus 1, and I'm going to say x is greater than or equal to 0. So if I do the same thing here, you know, where I sort of drew the line again, so let's draw that here, let's draw that here. Now what's really interesting about this case is that I've basically said that x has to be greater than or equal to 0. So here's 0, and you know, previously we drew a line like that, but this time, since it's restricted, it only goes through this part. So basically it's like that. And it includes this point. Why does it include it? Because we have that equal sign over here, so whenever it's an equal sign, you should always make sure that you sort of have a closed circle over here, and here it sort of goes on till infinity, right? So this is x, it sort of goes on after 0, as we said over here. And yeah, basically that's it. And so it does, so all this part that was there before is not included because we've restricted the domain. So once again, if we basically look at our sort of line of possibilities, so let me just draw this right here, and let me draw that right there, and let me just sort of label this one more time. So that's a 1. All right, so if we look over here, we can see that for the x, the lowest value for this function is 0. So this is 0. And basically, it sort of carries on after that. It carries on forever after that. And for the y's, the lowest value that we can see here is a 1. And I'm going to put a closed circle. Remember, closed circle means that we include it. So that's a 1. And it sort of goes on forever after that. So there we go over there. So this one is going to represent the domain, and this one is going to help us represent the range. So let's look at what the domain and range will be. So D, again, stands for domain. So again, it is all the real values, but there is a restriction on it. So here's how we write that. So we say x is element of reals, okay? And then we're going to put a bar. And this bar means that we're going to impose a restriction. And what's our restriction? Well, our x values have to start from 0 and beyond, right? And they have to include 0 as well. So we're going to say it's x is greater than or equal to 0. So this is the domain. So in other words, it's all the real numbers, but hey, we're imposing a restriction, which is it can only exist after, including or after 0. Now, what about the range? Let's look at the range. So if we look at the range, so this represents the range, well, we have a value of 1 over here, and that's the lowest value it can hold. So here, we say y is element of reals, because it means we're saying all, but we're restricting it. We're saying it has to be greater than or equal to 1. So it has to be greater than equal to 1. And remember, this equal to is important because we have a closed circle. The closed circle means we include it, okay? So what happens if we don't have a closed circle? Well, we'll look that up in the next example. In the next example, we have example 3, okay? So we have f of x is equal to 2x plus 1, right? And we have x is greater than 0. So let's basically see how this looks like. So now I'm just going to draw this again, okay? And again, this is going to be sort of my possibilities here. This is going to be the possibilities for the range here. And I'm going to say pick a red color. Oh, no, I'll pick a red color. So let's pick red. And once again, now this is greater than 0. So I'm going to start somewhere here. It's the same function as before. But what's interesting this time is that I'm not including 0. So here's 0, right? And I'm not including 0 because it's, as you can see there, there's a restriction. So what I'm going to do is I'm going to put an open circle. An open circle means that it does not include the 0. It does not include this point because we haven't included it here. So since it's not included here, what's going to happen is that if this point is 0, we're going to put an open circle over here. Now, we know that the function goes beyond that. So looking at the red, it's everything over here and sort of goes beyond. Oh, and by the way, this is a number 1 because, remember, of the y-intercept. And so for the y, same thing. Because of that open circle, we're going to put an open circle here. This is 1, and it goes above and beyond till infinity. So it goes right there, and like it goes forever, basically, till infinity. So now let's determine what the domain and range are. So the domain here is x is element of reals, right? And now we put a restriction because it doesn't extend forever, right? And this time we say x is greater than 0, which is pretty much, as we said, we've sort of defined the function that way. But the range is much more interesting. So y is element of reals, and here it doesn't include the 1. So we're going to say y is greater than 1, right? So observe the difference between example 3 and example 2 before. In example 2, we had an equal sign. So both of these had greater than or equal to. Whereas in this example, example 3, we simply have greater than. There's no equal to because of that open circle. All right, so let's do our last example for this video. There will be more examples after, but let's do our last example for this video. So let's do example 4. And here, basically, I'm just going to draw sort of a random function. So let me just draw, oops, I want to draw it with yellow. Let's do yellow. Okay, so let me draw a random function. So I have that here. I have that here. Let me draw it with red. Okay, so I'm going to draw something like this. Okay, and what I'm going to do now is I'm going to say that this is an open circle here. This value right here, okay, is -1. This value right here in the y is 1. This value right here, okay, is 2. And the corresponding y value for that last point. So again, I'm going to make this a closed circle there. That's going to be 3. So the question here is, just for this line right here, what is the domain and range? So let's take a quick look and see how. Let's see if you can figure this out while I'm doing it. Great. I would recommend pausing the video and seeing if you can get the domain and range. But if you're confused or you want to see this example, then follow along. So, oops, I'm going to do a yellow line just to be consistent. So let's draw sort of a yellow line here. So again, this will represent my possibilities for the domain, and this will represent my possibilities for the range. So, so let's take a look of where we're at. So as we can see, the leftmost value is -1, and it's an open circle. So because it's an open circle, I'm going to draw an open circle there. And as I move along to the right, I don't see anything until I get to 2, which I know is a closed circle. So I'm going to put 2 over there. And I know that everything, my possibilities, only extend between -1 and 2. So it's only between -1 and 2. Whereas let's look at for the range. So the lowest value for the range is 1 right here. Okay. So this is the value of 1, and it goes all the way up to 3, and it includes 3 because it's a closed circle right here. So includes 3 right here and everything in between. So it's everything in between, and we're almost done. So now, what is the domain? So the domain, I'm going to look at this. So it's between -1 and 2, and it does not include -1. So again, first I'm going to write x is element of reals, okay? And then I'm going to say it's between -1, and I'm not going to include the x. So it's just a less than sign, x, and then the highest value is less than or equal to 2. All right? And now let's look at the range. So R stands for the range. So y is element of reals, okay? And this time, it's between 1 and 3, and it does not include 1. So it's 1 less than y, which is less than or equal to 3. All right, so that's example 4. In the next set of videos, or in the next video, where I'm going to go through some more complicated examples.